Hi everyone. Give me just one more minute. I need to set up something. Till then nothing. Till then wait. Okay. So everything is set. Let's start. And today we are going to start a new chapter, bachcho. So we have completed electromagnetic induction in previous class, right? And today we will be starting AC circuits. Okay. Alternating current. And sometimes you have not understood, you may not understand it because it is like full of imaginations, right? And some difficult new terms you feel that in this chapter are there, right? But this is a pretty important and pretty simple chapter. Just have to understand a little bit, stress the mind a little bit, and then it is very easy. So last year in 2021, 3 questions came in JEE mains from this chapter, right? 3 question is a very high weightage. Okay. Okay, so Wardha is there, Silvassa, Jalgaon, Bade. Okay. Chalo, so without wasting much time, let's start the chapter. Okay. Good evening, everyone. Good evening, everyone. Good evening, everyone. Fine. So, first of all, if I talk about weightage, okay. So, JEE mains. Okay. So, in JEE mains, about 2 to 4 questions can come, okay, from AC circuits. And NEET, approximately 3 to 5 questions. Okay. More than 5 can also come. Right. So, pretty high weightage topic. Okay. And in AC circuits, actually, we are in continuation with electromagnetic induction. Okay. So we have studied something in electromagnetic induction, right? At the end, do you remember what we have studied? Mutual inductance, correct? Mutual inductance we have studied. And you should be very well versed with this electromagnetic induction chapter, because some of the applications of electromagnetic induction will be there, right? In fact, it is a continuation of that chapter. So this was the one of the slide which I explained you in in that chapter, which is AC generator. And an AC generator, the electricity that comes in our home is alternating current. Okay, you know the meaning of alternating current. The current or the electrons are not flowing in the same direction always. Okay, because when you feel about current, you feel like it is a pipe, the wire is a pipe, and the electrons are like water inside that pipe and it is flowing in one direction. No, it is not like that. It is basically the dance of electrons in the wire, alternating current. Okay, first, let's say this is a wire, this is the electron. First electron will go left, then right, left, right, left, right, left, right, left, right. This will happen, it will change the direction. And how many times it changes the direction, that is called frequency. Okay, and from where this changing of direction is coming? It is coming from this generator, which is used to generate the AC current, right? Big generators are there in power plants, like thermal power plants, okay, where coal is burned, steam is produced, that steam is used to run this this generator, the turbine, which is basically called turbine. The turbine is used to run, and the turbine is connected to the shaft of the generator. Okay, it is just like a motor, but in reverse direction. So when that motor or that generator is rotated, this alternating current is produced. Okay, I'll just show you one simulation. Look here. Okay, so this was the simulation, right? If you see the rotation, see, if there are 8 rotations per second of this coil, you can see the electron. These are basically the charges inside the wire. They are dancing like this, like this, like this, like this, like this, like this. This is alternating current. Means when the current changes its direction, acha, how many times it is changing direction in 1 second? 8 times. That is called frequency. Okay. 8 times it is changing means in 1 second, 8 times it is changing. In India, basically we produce an electricity of frequency 50 hertz. Means in 1 second, 50 times it is changing the direction. In USA, it is 16 hertz, 60 hertz. So in USA, the electricity which is produced is the electrons are changing direction 60 times in a second. Okay. So this is alternating current. Clear? I hope this is clear, right? Respond in the chat. Is it clear? Let me have a feel that you people are listening. Okay. Today's class will be a good level, means it is like the pace will be medium. Tomorrow it will be fast. Okay. Let's see how much we will cover. Chat में बता दो भाई. Tell me in the chat. You people understanding what I'm teaching? Okay. ठीक है. So AC generator is the reason why this current direction is changing. And since it is changing, it is altering. That's why it is called alternating current. Okay. So in the previous chapter EMI, we have seen why this current comes or induces in this wire because of change in flux. So flux was BA cos theta. If there are N turns, it is NBA cos theta. Theta is angular displacement, which is omega into T, angular velocity into time. So when I differentiate or when I find d phi by dt, I will get EMF. So how much is EMF produced? It is NBA omega sin omega t in this wire. Okay. And this EMF is sinusoidal. Means it is increasing, decreasing, increasing, decreasing. Correct? Like a sine curve. Maximum is NBA omega. So that is maximum EMF. And this we got the equation of EMF. Carrying forward this equation, we can find current also. Before that, let us see how many types of current can be there. There can be so many types of current, right? Basically, two divisions we do. One is called direct, one is called alternating. If a current is not changing the direction, it is called direct current. If a current is changing direction, it is alternating current. Okay. In direct and alternating also, there can be many types. So for example, you see this current. This is not going below x-axis. Means the current is positive. Voltage is positive. So it is not changing the direction, but it is pulsating, increasing, decreasing, increasing, decreasing, but not going negative. So it is a direct current, not changing direction. Similarly, here also you can see same current all over the time. This is perfect direct current. Okay. Okay. Then see this current. See this current. First increasing, decreasing, and then going negative. Then again it will go positive, then negative. Alternating current. Again, if I see this current, this was negative first, then it became positive. Means it is also an alternating current, but it is variable alternating current. Okay. Right? There is no symmetricity or some path it is not following, just like this AC current. Right? So alternating current basically continuously changes direction. Okay, I hope you understood about alternating current, right? So alternating current are used in our homes daily for daily purposes, right? So whatever you are getting the current in your home from switchboards, you are getting alternating. Okay, then you will put a charger and you will convert it into a direct current and will use to charge the mobile phone, right? Anyways, so if I talk about the cycles, right? since this sinusoidal curve is following, this is, we can call one cycle. Okay. So if I talk about how much degrees it takes to complete one cycle, so it takes 360 degree to complete one cycle, correct? If I go in circular motion. So how much it will take to complete half cycle? 180 degrees. So this will be like 360 degrees. This will be like 180 degrees. Okay. Till 0 to 180 degrees, the current was positive. From 180 to 360, it is negative. When is the peak value achieved? At 90 or pi by 2. Then negative peak is achieved at 180 plus 45, right? That is 125. सही कर रहा हूँ ना? So negative peak is achieved at 1. नहीं, ओहो गलत. 90 plus होगा ना, 270. ठीक. So here also the same thing. If I talk about the sinusoidal curve, this was the EMF produced in that AC generator. Similarly, the current also will be like this. Okay. If I talk about resistive circuit, right? Where we can say I naught is the peak current. Omega is called angular frequency, right? So basically, since we are considering that it is completing a cycle, we are assuming that it is a circular cycle. So one cycle, if it completes that means it has completed 360 degrees, right? So with what speed it is completing that circle, that speed is basically V, or we can say angular speed is omega. Okay, omega is equal to 2 pi f, where f is the frequency, right? And omega is angular frequency. Also, we can write it as 2 pi upon time period. Okay, so if I talk about 180, here half cycle will be done, then 360 half cycle will be done. Okay, here if I talk about the starting angle, that is 0 degrees. Okay, sometimes it may start from upside. Okay, that means it is a little bit aage, front. Okay, that is called leading. I'll teach you that. If it is starting from downside, lagging. Okay, chalo. Now this is the equation of EMF. Now if I want average value or mean value of AC current, average or mean, average for anything is total upon total time, right? For example, average velocity, total displacement upon total time. Similarly, average current, total charge upon total time. So what is average or mean value of alternating current? It is total charge flown for one complete cycle divided by the time taken to complete the cycle. Okay, so we can write here total charge flown upon total time taken. Acha, this charge is flowing in one cycle, right? So from here, Q I can write as IT or IDT. If it is delta Q, IDT, and dt, time I can take from 0 to t, 0 to t. So if I talk about average value of, let's say, this sine curve in one complete cycle, this is positive, this is negative, average kitna nikla? 0. Total how much? 0 degree se chalu hua tha, 0 degree pe khatam. Current starts from 0, ended on 0, means final minus initial is 0 minus 0 upon total time is whatever it is 0. So average value for a complete cycle is 0. If I talk about half cycle by integration, we'll get 2I naught upon pi. Please note this. Okay, acha, abhi you understand. In the upcoming slide, I'll give you the conclusion. Okay, so it is 2I naught upon pi, where I naught bachcho is peak current. Okay, peak current of the circuit. Peak current matlab this current. How much this will be, whatever it is. Okay. Now second value. Acha, sir, why we are finding average and this RMS values and all? The reason is actually this electricity was invented, but when it is commercially distributed, people want to get or want to earn money because they are giving a service. Those which companies are distributing the electricity, they want to earn money because they are giving some service. Okay, their cost is also there in creating that service. So how do they will put some meters to measure that current or to measure that power consumed by that particular house, right? So how they will measure it? First they thought, "Arey, chalo, let's measure the average value." Okay, so somebody used the current or somebody used the power for one cycle. Average came 0, means he used the power also, and average of the current is also 0. So they cannot calculate from here. It was a problem. So they introduced RMS, root mean square. How to find root mean square is, look here, just a second. Okay, so how to find root mean square is, actually for finding root mean square, we have to go back, start from square. Okay, so बच्चों क्या करना पड़ेगा उसमें? Look here carefully. So square करो सबसे पहले current का. We have done square, very nice. Now we will take mean. Okay, so mean के लिए the total current flown in time 0 to t, the total current flown in time. Sir, why integration? Because current is changing continuously, so we cannot sum it up. Current is increasing, decreasing ना, so we have to integrate in t time. Average निकालने के लिए divided by total time. Clear? So what I did? First I did square, then I did mean. Mean means total current upon total time. Then I have to do root. तो मैं इसका बच्चों क्या कर दूंगा? Root. In this way we calculate IRMS. Okay. So let's read here. RMS value of alternating current is defined as the value of steady current which will generate the same amount of heat in a given resistance given time as is done by AC current when maintained across the same resistance. मतलब heat means energy. Okay, so RMS value of current will give you that how much heat is generated or how much power is consumed, okay, for a particular time or for a particular load, whether it is bulb or tube light or something. So if I calculate this RMS for some time for sinusoidal current, okay, so you will get it as I naught upon root 2. This is RMS. Sorry, this is peak current. Okay. Chalo. So this is RMS, root mean square. Start from back, first square of the current. So I did a square. Then I took mean. Mean means total current divided by total time. Then root I took. Root. Okay. Chalo. So two things we have discussed. One, we have discussed IRMS. Second, we have discussed I average. IRMS is I naught by root 2. I naught is peak current. If I calculate the value of 1 by root 2, it will come 0.707. Means RMS current is bachcho. Sorry. Oh. Okay. RMS current is 0.707 times of peak current. So this was the peak current, let's say. This is the peak current. So RMS is this one, 0.707, less than peak current. Then if I talk about average, which was 2 I naught by pi, I naught is peak current. So it is 0.637 times of peak current. So this is average. Okay, clear? Chalo. So whatever you want to note these two formulas, very important. Okay. From next time, we will not be going in this much detail. We will be directly calculating RMS. RMS is I naught by root 2. Average is 2 I naught by pi. Okay. For sinusoidal and cos wala current. Okay. Chalo, we should move forward. Okay. So if I talk about average current in full cycle, just a second. Average current in full cycle, that was 0. Okay, in this full cycle, average current was 0 because positive cancels negative, 0. RMS was V naught by root 2. What I'm talking about? I'm talking about voltage. Okay, so for voltage also same. Average 0, RMS V naught by root 2 for full cycle. For half cycle, average is 2 V naught by pi and RMS is V naught by root 2. So you can see here for half cycle and full cycle, the RMS is same. That's why the meters that are put in our houses now, they will measure RMS values, and then we can find the power. They will calculate VRMS, IRMS, and one more thing called power factor, cos phi, that I'll tell you. So for calculating power, IRMS into VRMS into cos phi, they will get the power, how much it is consumed. Okay. Let's do a question. Let's do a question. I'll give you 2 minutes. Try this question. I'll read the question once. An AC source rated 220 volt and 50 hertz. 50 hertz means 50 cycles wala, India, is connected to a resistor. The time taken by the current to change from its maximum to the RMS value is. Do you remember RMS? I naught by root 2. Okay. Try once. 2 minutes. And type your answers in the chat. Huh? Oh, I will just off the video so that full question is visible to you. I think something is hiding, taken by, no, I guess. Chalo bachcho, let's do. Quizzy ka answer aaya? Anybody got any answer? So this question came in JEE Mains, huh? Simple, very simple question. So look here. Those who have not got the answer, look here. Okay. So let's say this is this is which type of graph? Maths mein padha hai sabne? Cos na? So here let's say the current is I is equal to I naught cos omega t. Okay, cos wala graph hai. It can be, right? Okay, Rajkot. I think this is correct answer. Huh? Let's check. So I is equal to I naught cos omega t. Now here it is the maximum current, which is I naught. And in the question, it is telling there is an AC source rated 220 and 50. So 220, 50. Right? It is connected to a resistor. The time taken by the current to change from its maximum to RMS. Maximum is I naught. RMS बच्चों यहाँ कहीं होगा, which is I naught by root 2. Okay. And this graph is of cos. Means this current is not sinusoidal. It is cos. Cos wala current hai. Okay. So when I put this much time we have to calculate. How much? From changing from I naught to I naught by root 2. This time we have to calculate. Okay. So let's say time here was 0. And let's say time here is something t. Okay. So how much is the current at t time? So at t is equal to 0, current is 0. At t is equal to t, current is I naught by root 2. Yeah, RMS current. I naught by root 2. So we can put this condition in this equation and calculate, right? Acha, one more thing. What is omega? Omega is 2 pi f. Frequency is given as 50 hertz. So I can put it here and I can calculate omega. Sir, why you are calculating omega? Arey bacha, idhar rakhna padega omega. So 2 pi into f is 50. So 100 pi. So let's put all these values. I, which is I naught by root 2 is equal to maximum is I naught cos of omega is 100 pi into time. This time we have to calculate. Correct? So I naught से I naught का happy birthday 1 by root 2. So cos 1 by root 2 कब आता है? When we get cos theta is equal to 1 by root 2 at 45 degrees. So pi by 4 is equal to 100 pi into t. Pi से pi का happy birthday फिर से. So time is equal to 1 by 400 seconds. अच्छा ऐसा तो कोई ऑप्शन है ही नहीं. So let's calculate it more. So divide करते हैं. So it will be like 0.25 into 10 to the power minus 2. अच्छा, this can also be written as 2.5 milliseconds, right? यहाँ पे 2.5 into 10 to the power minus 3 seconds, or can be written as 2.5 milliseconds. Option C is correct. So Rajkot was correct. Very nice. Okay. Note the answer and try by your own quickly. JEE Mains का question. Very big बच्चा question, right? चलो. Let's move to one more question. Quickly. Try. 2 minutes. Same question, मतलब same year it came again. I'll read the question once. An alternating current is given by the equation I बराबर I1 sin omega t plus I2 cos omega t. So current is flowing like this, huh? It is asking the RMS current will be. Okay, I got one answer. Chale bhai, let's do it. Okay. So it is saying what is the RMS current. Okay. Equation bachcho is given as I is equal to I1 sin omega. Acha, let's say equation was only this much. How much will be the RMS current? RMS, sir, you only told that it is I naught, which is maximum or peak by root 2. So here, sir, we can say for this equation, it is I1 by root 2. Lekin, this is not the equation. The equation is I1 sin omega t plus I2 cos omega t. So isko hatate hain hum. Let's move it. Okay. Plus I2 cos omega t. So what can be done to make it in this type of form? Let's say I dash either in sine or in cos. ऐसा कुछ बन जाए, then we can take this quantity and we can like divide by root 2 and we'll get the RMS. Okay. So we can do one thing. देखो, I1 sin omega t. Can we write I2 sine of omega t plus pi by 2? Correct. ऐसा भी लिख सकते हैं, right? Now from here, I can say if I1 current is like this, if this is, let's say, I1 current, then I can see I2 current is flowing with extra pi by 2. मतलब I2 जो current है वो pi by 2 से आगे चल रहा है इस current से. आगे means leading. अच्छा, leading के लिए we go anti clockwise. ओके, एंटी क्लॉकवाइज। सो बच्चों हम यहाँ से चलना चालू करेंगे till 90 and we'll get the I2 current somewhere here. This is called phasor diagram, है ना? It is the representation of the phase differences. So I1 is running at let's say 0, तो I2 उससे कितना आगे है बच्चों? I2 is 90 degrees. अच्छा, अगर I2 नीचे बनाता मैं, so it is lagging, I2 is behind I1. Okay, so अगर मुझे इसका रिजल्टेंट निकालना है तो अरे we will use Pythagoras, right? So Pythagoras के लिए I will say that I dash is equal to under root of I1 square plus I2 square. This is the resultant current. Now I want RMS. So IRMS is equal to the net current by root 2. So it is under root of I1 square plus I2 square by root 2. So which is the correct answer बच्चों? Option C. नहीं C नहीं होगा, option A. Okay. राजकोट B कैसे आ रहा है? अंडर रूट भी तो लेना होगा। चले भाई, shall we move? Now AC हमने पढ़ लिया, what is AC? Alternating current. Now I have a AC source. Okay, this is my generator, let's say. और इस generator से I connected a resistance. How will be current? What will be the things happening that we'll see now. Okay, so first we will connect resistance, then we will connect capacitance, then we will connect inductor, and then we will connect all the three. All the three means RLC. Clear? So first I connected resistance. Acha, resistance is very, what we say in Hindi, bhola. Okay. Resistance is not so cunning. So it will allow the flow of current instantly as it gets the voltage. जैसे voltage मिला उसने current flow करना चालू किया. But inductor is very cunning. Inductor will say, no, I'll oppose this current. You apply some voltage. I will not allow initially. Then slowly I will allow. Capacitance say that, okay, initially you let it go, but finally I'll become open circuit. I will not allow. So resistance is very simple. Its life is very simple. As you apply voltage, you will get the current. Simple. So if I want current and if I applied this AC current, AC voltage, then what is the current? E by R. Simple. E is E naught sine omega t by R. So I can write I naught sine omega t of I naught is what? I naught is maximum current. That is E naught by R. Simple. And how will be the current pattern? Look here. So if this green is the if this green is the, this is not E naught by R. This is E naught only. Wait. Let me correct it quickly. Okay. So this is just a second. So let's say this green wala is the voltage. Okay. This is the voltage. This green wala is the voltage curve of alternating voltage. And for that corresponding alternating voltage, we will get current. We will get current. Sir, why it is reduced? Because how we will get the current, bacho? We get current by dividing EMF. By dividing EMF by resistance. In this way, we get the current, right? So if we divide means the value decreases. That's why the current is less than the voltage. Okay, but you can see when current is when this EMF is 0, current is also 0. When EMF is again 0, current is 0. When EMF is 0, current is 0. When EMF is maximum, current is also maximum. Means they are going hand in hand. There is no phase difference between them. Clear? Value is less more, but they are going hand in hand. They are going together. Just like wife and husband. Anyways, so let's make a phasor diagram. What is phasor diagram? Phasor diagram is the representation of the phase difference between two quantities or three quantities or more than three quantities also. So for example, my voltage is like this. Means my voltage is having a phase of, let's say, 0. So current will also have a phase as 0. My voltage is having a phase of, let's say, 45 degrees. So my current will also have a phase of 45 degrees. So there is 0 phase difference in resistive AC circuits. Clear? So current and voltages across the resistance are in phase. I hope you understood. बच्चों समझ में आ रहा है? Are you understanding? Because there is very much silence in the chat box. Understood this one? What I am teaching? Silvassa, Vardha, Vardha 1, Vardha, Vardha, capital Vardha, small Vardha. 4 Vardhas are there. Oh, I think 4 sections. Rajkot, Jalgaon, Bid. What about others? Only Rajkot is replying. थोड़ा सा YouTube पे देख लेते हैं. चलो. I hope this is understandable, right? So resistance and voltage go in hand. They have 0 phase difference between them. Okay, whenever this voltage will have peak value, current will also have peak. Voltage 0, current also 0. Chalo. Now let's talk about capacitors. So capacitors, in capacitance, I think you have learned that equation of current in capacitor. Correct? कुछ याद आ रहा है? Try to remember. I is equal to voltage of capacitor and current of capacitor. 2 equations were there. How voltage and current varies with time. है ना? Initially capacitor will behave like a wire. Okay, so initially the current will be maximum. कुछ याद आ रहा है equation? Shall I write the equation? I is equal to current initially is maximum. Right? So I is equal to I naught e to the power minus t by tau. ऐसा कुछ याद है? So when t is equal to 0, put here 0, t is equal to 0, you will get I is equal to I naught, which is maximum current initially. This was current equation. Voltage का आता था V naught 1 minus e की power t minus tau, where tau was time constant. Correct? Anyways, so here also, when this alternating current will apply, this capacitor will show this type of behavior. Look here, what type of unprofessional behavior it will show. So let's say this is the voltage curve. Okay, sinusoidal curve. Voltage starting from 0, going maximum, then 0, then minimum, then 0, then something. How current is behaving? Just take a look. Current is starting from some value. When voltage is 0, current is having some value. And that sum is maximum value. Because maximum, minimum, maximum, minimum. Clear? So here the phase difference between the current and the voltage. Can you see here? This is the voltage. Voltage is maximum. Current is 0. Then voltage is 0. Current is maximum in negative direction. Then voltage is maximum. Current is 0. Means they are separated by a phase of 90 degrees. Okay. अच्छा, who is front? मतलब कौन आगे चल रहा है? Who is moving first, taking the steps first, current or voltage? Current is leading. Current has started already. Voltage is 0, current has started already. So in case of capacitors, current leads by 90 degrees. So that we'll see, wait. So look here, AC circuit with capacitor. ध्यान से देखना. So this is the voltage that we applied, or this is the EMF that we applied in the circuit. Okay. So for calculating current, I have used this equation of capacitor Q is equal to CV. Okay. So in place of voltage or in place of EMF, I have put this value E naught sin omega t. देखो इधर ध्यान से. And then to find current, I want how much charge traveled per unit time, or dq by dt. So I'll differentiate this equation and I'll get C का C रहेगा, E naught का E naught रहेगा, sin का differentiation is cos omega t, and omega t का differentiation is omega. So from here we get this type of equation of current. Current का equation बच्चों, E naught by something something into cos omega t. Can you imagine this is, if I compare this equation, with E naught upon R cos omega t. So kya, I can say that this is a type of resistance only. This 1 upon omega c is a type of resistance only, but it cannot be called as resistance because resistance is not variable. In this case, it is variable, right? Okay, ये change होता रहेगा, right? So this is not, first of all, resistance. So we'll not call it resistance. We will give a different name. We will call it as reactance. Since it is reactance of capacitor, so we'll call it as capacitive reactance. Okay. So it will be called it as capacitive reactance, which is just like a resistance of capacitor. Okay. If omega changes, it will also change. If capacitor changes, it will also change. Right? So here it is. Acha, cos ko I converted into sine, and I found that EMF is E naught sin omega t, but current is I naught sin omega t plus pi by 2. मतलब current is forward. कितना? Pi by 2 से. ये सर कैसे किया? cos omega t को भाई sin pi by t, pi by 2 plus omega t लिख सकते हैं, right? Basic maths. So pi by 2 से आगे चल रहा है, means current is leading by 90 degrees. Okay. So capacitive reactance याद रखना है 1 by omega c. Okay. 1 by omega c ohm, and it is denoted by XC. Current through the capacitor leads voltage across it by pi by 2. So current is leading the voltage. Clear? Phasor बनाएंगे तो phasor simple है. This is the same diagram which I shown you. So current is starting earlier when voltage is 0, right? So voltage बच्चों अगर 0 है तो current is forward by 90 degrees. Why anti-clockwise? Because for forward we assume that anti-clockwise we have to go. Okay, so current is leading by 90 degrees. Okay. Okay, whatever you want to note it quickly. थोड़ा सा speed में note करो, right? Shall I go back? Tell me in the chat where you want to note. Chalo. Let's move forward. So now let's put inductor. अब inductor की बारी. Inductor is cunning. It does not allow the change in current. You will apply voltage, it will not change. Okay. चलो, let's see. So यहाँ पे 0 voltage apply किया है. Sorry. This is the voltage curve. Okay. So let's say voltage applied here is the maximum voltage. For maximum voltage, we are getting 0 current because, as I told you, inductor is cunning. It does not allow the change of current initially. Okay. So for maximum voltage, 0 current is there. Means voltage is leading. In case of capacitor, current was leading. So we can call here that current is lagging. Voltage is leading, current is lagging by pi by 2. So again, the same derivation here also we can do. We can write the equation, then put the value, and then differentiate it. After differentiating, we'll get this final value. Okay. So in place of resistance, we are getting omega L. So we cannot call it as resistance because it is not a resistance. It is a different thing, but it behaves like a resistance. So we'll call it as reactance. And since it is the reactance of inductor, so it is called inductive reactance. लिख लेना. Inductive reactance. Okay. Inductive reactance. So it is denoted by XL. XL is equal to omega L. So here the current is lagging the voltage by pi by 2 and XL is equal to omega L ohms. अच्छा ये लिखा हुआ था. Oh, it was already written. चलो. Sir, lag कैसे? When we derive the formula, we are getting minus pi by 2 here. That means current is lagging. Chalo. So phasor diagram. If voltage is at 0 degrees, current will be lagging by 90 degrees. Okay. So lagging is clockwise. Please note quick. Then we'll do some questions. अच्छा, here in this diagram, plus 90 लिखा हुआ है, right? It is basically Vm cos omega t. Anyways, plus 90 matlab the voltage is leading. Okay. And here is no plus 90. So current is lagging. So what can we conclude from here? Okay. So we can say that in resistance, current and voltage are in same phase. In case of capacitors, current leads by 90. And in case of inductor, current lags by 90, then voltage. And we have also studied something called reactance. In place of resistance, we can call this as a substitute. So for resistance, the reactance is resistance only. For capacitor, the reactance is 1 upon omega c. In place of omega, if you write 2 pi f, then it will be 1 upon 2 pi fc. Okay. And if frequency becomes 0, then reactance will become infinite. Okay. Frequency 0 matlab DC circuit. And in DC circuit, this is a capacitor. Capacitor does not work. Okay. समझ गए? If frequency is 0, means current is not alternating. Current is straight. So that is a DC circuit. And in DC circuit, capacitor don't works. Capacitor behaves like an open circuit. Clear? Similarly, in case of inductor, the reactance is omega L. In place of omega, if you put 2 pi f, then it is 2 pi f L. And then if frequency is 0, bachcho, then XL will be also 0. Okay. So in DC circuit, when frequency is 0 means a DC current. In DC current, if I put an inductor, there will be no effect. Okay. It will behave like a closed wire. Clear? Clear? Chalo. So now how can we remember, sir, that what is lagging, what is leading? Just remember only one thing. What one thing? Just a second. Inductor L. By inductor is ka inductance is L, correct? So I stands for current, L stands for lagging. Okay. So inductor में current होता है lag. किससे? Voltage से. In inductor, current lags by voltage, and vice versa for capacitor. So if in inductor the current is lagging voltage, so in capacitor current will be leading the voltage. Correct? अच्छा, कुछ ट्रिक्स और होती हैं जो कई वीडियोस वगैरह मिल जाएगा. CCL करके बोलते हैं. So capacitor current lagging and IPL. Inductor potential lagging. Means in capacitor the current is lagging Okay. In capacitor, sorry, current is leading, not lagging. And this is a bit confusing. That's why I have developed this trick. Acha, anyways, I'll not tell you multiple tricks. Look here. Remember this trick only. Inductor L yaad rakho. Inductor I stands for current. L stands for lag. Means in inductor, current lags. So in capacitor, current will lead. Simple. Chalo, let's do a question. Again, this question again came in JEE Mains 2021. Try the question. जल्दी से करो फास्ट आरएलसी नहीं हो पाएगा आज हो आंसर्स I'll just turn off. So let's see the answer. So it is telling what happens to the inductive reactance. Means inductive reactance बच्चों क्या होता है? XL. XL we have studied what it is, omega L, or we can write 2 pi FL. Clear? What happens to the inductive reactance and the current? Okay. So current in a purely inductive circuit, if the frequency is halved. Okay. तो बच्चों क्या half कर रहा है ये? Frequency half कर रहा है. Still you didn't got any answer? Chalo. So let's see what will happen. So if I talk about, it is telling that frequency is halved. मतलब f की जगह f/2 हो गया है बच्चों, f/2. So XL will also become XL/2. Means inductive reactance will be halved first of all. So inductive reactance will be doubled. ये गलत. Both inductor will be doubled. ये भी पता नहीं है. Option B, inductive reactance will be halved. ये sorry, ये गलत हो गया. ये वाला गलत, ये वाला भी गलत, because doubled नहीं होगा, half होगा, right? A option also halved and B option. Now there is a doubt in A and B option. Let's come to the second one. Current. Current is I naught sine omega t, or I can write E upon XL sine omega t. If XL due to half of the frequency will be half, so current will get doubled. I will become 2I. So I can say inductive reactance will be halved and current will be doubled. Okay, option B is the correct answer. Chalo, let's move to next question. Acha, take this question as homework. Kitne questions hai? Take this question as homework. Please note the question quick. And then chutti. So tomorrow, bachcho, we will be discussing LCR and resonance. And we will be doing a lot of questions. Come on time. Acha, any doubt is there? Koi doubt hai? Quickly, I will revise orally, hai na? Pay attention. Question bhi note karte jao and listen to me also orally. Okay. So, bachcho, we started the story with the last topic of EMI, that was mutual inductance. Sorry, not mutual inductance. The AC generator of the last topic. So in AC generator, NVA omega cos omega t was the EMF developed by the AC generator. Okay, so from there we got the EMF equation, that is E is equal to E naught cos sine omega t. Now this EMF we have analyzed and we found two values. Okay, so that one value is called the RMS, and another is called average. RMS is I naught by root 2 or V naught by root 2 for a whole cycle, and average is 2 I naught by pi for half cycle, right? And if I talk about for whole cycle, the average is 0 because positive and negative will cancel out. Then after that, what we have studied, निकाल लेते हैं, ये लिख लिया question. Have you written this question? Okay. So उसके बाद what we have studied? उसके बाद we have studied when we will put resistance in this AC alternating current source or generator. So what will happen? How will be the current and voltage? So current and voltage will be in phase. Okay, जैसा current वैसा voltage, only the differences of values. If I put it in capacitors, means capacitor if I put in AC circuit, then in capacitor, the current is leading the voltage. Okay, so for 0 voltage, you are getting some current. But for inductor, current is lagging the voltage. So for maximum value of voltage, you are getting 0 current in case of inductor. Then I told you a trick to remember this, है ना? Inductor L, I for current, L for lagging. So in inductor, the current is lagging. Vice versa, in capacitor, the current is leading by pi by 2. Okay, we have seen some derivations also for that. So that much is done in today's class. In the next class, we will be starting LCR circuits. Okay, and also resonance. So please try to do some questions, revise it, and come tomorrow. Okay, that's it. No doubt, na? Okay, so I'll end the class. We'll meet tomorrow. Till then, bye-bye and have a good dinner.